All right, so we're looking at something called trigonometric identities. We're doing some proofs where we have to show that something is true. And we're going to do that by getting both sides equal to the same thing. Now, one thing that we can't do when we're solving or proving identities is that you can't add and subtract from both sides. You can't divide and multiply on both sides. So it's not like we're solving an equation. We're really just going to be doing a lot of substituting and then simplifying things through basic algebra stuff that we've known for a long time. I'll give you plenty of examples and give you a chance to try this out as well. But I'll give you a few pointers to follow that will make life a lot easier for you while you're doing these. Some people find these very straightforward and very simple because they see the parallels between what this is and basic algebra or even basic elementary math. And some just see a bunch of sines, cosines, and cosecants and they freak out. Don't freak out. It's not as big of a deal as you might think it is because there's no numbers on here really, and you're not solving for x anymore. It's a different type of problem. Okay? But as soon as you get into it, you'll find that these things kind of start getting easier and easier the more you do them because you learn the rhythm. You learn like, oh, the same thing I did in this last problem I'm doing here. And once you see the repetition throughout the different problems, it becomes easier. So keep moving forward as much as you can, and you'll find like, okay, and you might even go back to some problem you skipped and see, oh, that's how I'd solve that problem. It's it's kind of like this problem, but the things are switched or something. So it's kind of a perseverance type of week for that type of thing. So the general approach for proving these identities is that you're going to see different trig functions that you're going to substitute in something equal to them. So if you see a secant, you're going to substitute 1 over cosine. See a cosecant, you're going to substitute 1 over sine. You see a cotangent, and so on. So all these you can just substitute in. And the goal is to get everything to be sines and cosines, right? So anything that's not a sine or cosine, like here, tangent squared, you're looking to replace that with something else that has sines and cosines. So you can use all of these. A little reminder that right here, this trig identity, a long time ago, like 7th grade, maybe earlier, was called a squared plus b squared equals c squared, right? This is Pythagorean theorem. And then in this class, we started off by looking at the unit circle centered at 0, 0, and that equation was x squared plus y squared equals r squared, right? And then we finally said, well, this is a unit circle, so the radius is always going to be 1. So that changed into a 1. And then we finally saw last week that the run, or the x, is the same as cosine. Just do that. Right? And that the rise is the same as sine. Right? So what you're seeing here is just another version of Pythagorean theorem, like an a squared plus b squared equals c squared, just with things substituted in, for the higher math. Right. So, and we have two other versions of this that we can use. So if I subtract sine squared on both sides, so if I just basically move that over, right, I'll have cosine squared theta equals 1 minus sine squared theta. So if I ever see a 1 minus sine squared theta in any of the problems, I can replace it with a cosine squared. And generally we're trying to make the problem more simplified. So we're replacing something that's bigger, like this has 2 terms, with something that's smaller. And maybe we'll have to add things or cancel things out after that. And then we can also do the other way. If I subtracted cosine squared on both sides, then I'd have sine squared theta equals 1 minus cosine squared theta. So all three of these, if you ever see a cosine squared theta plus sine squared theta equal, you can replace it with just the number 1. And again, that makes the problem or the identity shrink in size and makes things more simple and hopefully closer to solving the problem. For each of these, you also can apply any power. So if secant theta is 1 over cosine theta, then secant squared is 1 over cosine squared theta. So all these have that quality. You can use, with or without to the second power. Same thing with cotangents and so on. Let's also, don't forget, we still have tangent of theta. Right? That equals rise over run, sine over cosine. And this could be tangent squared. This could be, all sorts of things. So actually I'll put that on here just because it's on number 1. So if we need to, we have the squares on there. Alright, so general steps. You want to look at the problem. Let's look at A and note what is substitutable. So anything that's not sine or cosine, that's the first thing I want to do. So on here you can see, let's go green, that we have tangent squared x. So that means I can use this and substitute in that for it. And on the right hand side, I have 1 minus cosine squared. Right? So that would be found right over here, 1 minus cosine squared. So I can substitute in sine squared for it. So before you even begin, you're kind of scanning around before you start knowing what you're going to substitute, as opposed to let's just kind of work on this and then we'll get to the next thing later. Have a plan before you start and then start going. It'll make life a little bit easier. So for the first one, right, I'm going to substitute this for sine squared x. Notice how it changed from theta x over cosine squared x. And then the cosine squared that's already here, don't need to do anything. That just stays the same. So times cosine squared. And then on the right-hand side, I'm going to substitute, like I already saw, sine squared theta for that. So I made that side smaller. So I simplified both sides. I didn't add or subtract or multiply, divide anything to both sides. I'm just treating the left-hand side like its own thing and the right-hand side like its own thing. The two different sides of all these problems will never interact with each other. Your goal is just to have them be the same. All right, and then we just need to simplify, do a little bit of algebra. So what I like to do on these the first time through is always put in a basic fraction problem. So if you ever get stuck and you're like, I don't know what to do next, note the pattern here and just write a simpler problem with numbers only. So this would be the same as, instead of sine, I say it's 3. Instead of cosine, I'll put 4. So it'd be over 4, and then times 4, and then it's going to equal 3 again. So ask yourself, for this simple problem with just numbers, what would you do to solve it? And then you say, yeah, just the 4's cancel out. So if the 4's cancel out in this situation, and we end up with 3 equals 3, the same thing happens over here. The cosine squareds just cancel out. So if you can see the parallels between a basic arithmetic problem from elementary school with what we're doing here, all the rules are the same. So don't overthink it. Usually when you find out, if you get stuck, and then you find out what the solution is, you're going to be like, really? That's all it was? It's not going to be some grand thing that was way beyond your comprehension. It's going to be some basic piece of knowledge you already knew. It's just trying to come up with it in the moment while you're looking at all these sines and cosines everywhere. So the end of each problem looks like this. You have the same thing on both sides, and if you do that, you have proven the identity. So that's the general run-of-the-mill identity solving problem. Okay. So let's try one more, and I'll let you do number 1. Yeah. Let's go down to B. Now we have secant squared, and we have tangent squared. So we have tangent like we already did up here. So we can just look at another problem that had tangent squared and see what we did, or we replace it with that. So we know on this problem, same thing. I'm going to replace this with just like I did before. And this is why the more you do these, the easier it gets, because you're going to see things repeating themselves. And now we have a secant squared, which we know is right here. Secant squared is going to be 1 over cosine squared. So I'm going to replace secant squared with 1 over cosine squared, and then tangent squared again with sine squared over cosine squared, and simplify. The tangent, slope, rise over run, sine squared over cosine squared. And then plus, put that black, plus 1. All right. So how do we simplify this problem? All right. And usually you're simplifying the side that has more stuff. So the left-hand side is simplified it's going to get. So you might be asking, well, how do I know which side to do? Last time it was, the left-hand side we did stuff, not so much the right-hand side. And this time, well, there's more things going on the right-hand side. There's two terms, so that's kind of a hint that that's the side you want to be looking at. Okay? And the question is, well, how do I simplify that? So if you're not sure, let's go back to what we did before. Simple problem, right? So last time I did this, I put like 3 over 4 times 4 to mimic this situation right here. So I'll write something similar. What if I had 3 over 4 plus 1? How would you simplify and combine these? What would you do? What's the strategy called? Find the what? Find the common denominator. So we'd multiply, we'd look down here, say I need to be 4, and we multiply this by 4 over 4, right? And then I'd have 3 plus 4 over 4 as my answer, which would be 7 over 4, but for our purposes, we'll just leave it here. But you can see that this is the same thing. So right here, I'm going to multiply by this, the common denominator here. Instead of 4, it's now cosine squared. So I multiply top and bottom by cosine squared. So this is really the skill, is how well do you know your fraction rules from elementary, and then, of course, adapting it to trig. And if you get that skill, you get the, that's what we're really trying to get at. And you're always looking for what's the, basic rule that I learned a long time ago that I can use here, then you'll get the hang of this pretty quickly. So it's somewhat intimidating to see all this stuff, and then you realize, so it's really just a bunch of fraction and algebra rules? Like, yeah, that's pretty much it. And then the top here, like we just have everything over one denominator now. Right, so it's going to be over cosine squared. And the numerators, I'm just adding these together. So that's why I wrote it as 3 plus 4, because it's just going to be sine squared plus cosine squared. All right. Anybody see the next step? Well, we're trying to get this right here. And the bottoms are already done. So we're halfway done. I need to get the top and bottom to match for me to be finished, right? Like we did up here. These things match exactly. Right now, the bottoms match exactly. The tops don't. So that lets me know that this thing, I need to somehow turn it into this, right? If I do that, I'm finished. Then I'll have 1 over cosine both sides. And then what do we do here? Yep.
Oh, I was just going to say one of the rules that we have at the top is that cosine. Oh, no.
Yeah, you're right. Yep, we have right here. Cosine squared plus sine squared equals 1. So our last step is just substitution one more time. And I can write this as 1 over cosine squared. Now you'll notice that it's written up there maybe cosine squared plus sine squared, but that's the same thing as sine squared plus cosine squared, right? So we are okay with that. So we have 1 over cosine squared theta, both sides, and we're finished. Now some might say, well, we can just leave it as secant squared the whole time, and then the last step we convert this to secant squared and have secant squared equals secant squared. That wouldn't be wrong, but I find in general just telling you to make everything sines and cosines everywhere, it's pretty universally true, and it works all the time. So, but if you find a different way that shows all the steps and does everything, show it to me and I'll let you know if it works, because there definitely are different ways of doing this. All right, your turn. Go ahead and try number 1 here. Start by figuring out what you're going to substitute, and then try to combine things together. So we know that secant squared from above, right, is 1 over cosine squared. And then we know cosecant is 1 over sine squared. Okay. And that all equals 1. So somehow this all cancels out or comes together. And as soon as you see this cosine squared, and there's a cosine squared and a sine squared, you might automatically gravitate towards this. Cosine squared plus sine squared equals 1. So if I'm trying to get this thing equal to 1, you can always kind of gravitate towards, like, I think this is going to end up being used. Right? So having this sheet out while you're doing your assignment definitely makes a big difference, because you're going to see things that for definitely will not work, and then like, oh, this one might be the one I use. Right? I can eliminate a few things, you know, right out the beginning, like cotangent. If there's no cotangent, I'm not going to use that, right? But this one you use quite a bit. This unit circle identity is very popular. So the question is, do you know how to simplify a complex fraction, these are called? So this is where you go over here and ask yourself, instead of 1 over cosine, do you know how to simplify 1 over 1/4? Right? As long as you know how to do that from elementary school, you're good to go. Right? Back in the day, some of you might have written it like this instead. They mean the exact same thing. 1 divided by 1/4, 1 divided by 1/4. These are identical, right? These mean the exact same thing. And you learned something called keep, flip, flip, probably, and you just got an answer of 4. So basically, if you start with 1 divided by 1 over something, the answer is just whatever that denominator is down here. So that means down here, same thing, this is just going to simplify to cosine squared. Which means this is just going to simplify to sine squared. And as we already know, cosine squared plus sine squared equals 1. Okay? Now, it's kind of good and bad. You started with learning these fraction rules, but if you don't know why they work, it's just a random magic thing. So after a while, especially right now, you want to get away from this. We don't want to do things thinking, but it gives me right answer. I have no reason why, but it gives me right answer, so I'm okay with it. You're in the level of math classes where you want to know why things work. So the reason why it works and why you just change magically go from division to multiplication with no explanation whatsoever is because if you did it on this format, you'd multiply top and bottom by the reciprocal. So the reason it works is that you're actually multiplying by 1. 4 over 1 divided by 4 over 1, that's the identity property. But we choose the reciprocal because that cancels out. And now that's why it's multiplication. It's because we're multiplying by the reciprocal. Right? And that gives us the answer. And if we know why things work, when we start doing this higher math stuff, it'll be a lot easier as opposed to just following a bunch of, elementary school rules that have no meaning behind it. Okay? All right. Go ahead and try number 2. Give that a go. More substitutions this time.
Let me do my work. I'm not doing it.
All right. So on this one, we have some fractions to simplify on the right-hand side, and you can see it's just 2 fractions being added. So another hint to, well, let's just look at what would you do with numbers. So if I was adding 3 over 4, if cosine is 3 and sine is 4, and then I'd be adding 4 over 3, right? Because they're just reversed over here. How would you add those 2 fractions? And you would say, common denominators again, right? This would be 4 over 4. But this one would be 3 over 3. So they both have a denominator of 12. So same thing over here is that this one, I'll have to multiply this fraction by cosine over cosine. And then this fraction by sine over sine. So just the denominator of the other fraction. Just like you would with, when you learn to add 2 fractions, right? Same exact thing. So if you can see, again, the parallels of, I know how this works. I wrote this basic problem here, solved that, mimic the steps, just, substituting in sine and cosine for 3 and 4, and you're good to go. So we end up with, on the top, cosine squared, A. The bottom, over here we get sine squared, A. And the denominators are now the same, right? 3 times 4, or cosine, or I'll write sine, cosine, just so it's the same exact order as it is over here. And then, last step, once again, cosine squared plus sine squared, we know that equals 1, so we are done. Yeah. So you see some of the same patterns. You see another like fraction, background problem. You see cosine squared plus sine squared equaling 1 again. Like I said, the more you do these, the more you see things repeating themselves. So keep that in mind. Like next time you have an identity on one of your homeworks and it's just 2 fractions with different denominators, you come back to this problem, you could pretty much follow the same steps. Of course, it might be, something might be slightly changed, but the process is the same. So having your notes out and having everything out definitely helps. Okay. All right. Lastly, let's look at this one. Now this has, it's a little bit bigger. It's kind of has a little bit more going on. Now you could try this on your own and see where it goes. All right. But it's very similar to the one we just did. But I'll go through it with you. So the question is, when you have this much going on, where do you start, right? And I'll take you back to the first problem. Anything that's not cosine and sine, substitute out. So even though this looks like it's got more stuff going on the left, there's nothing that work for us to do. It's already simplified. There's nothing that cancels out anything. So I'm pretty much stuck with whatever I see on the left-hand side here. So once you realize that, like, well, there's nothing I can do here. And yeah, we had problems earlier where it might have simplified to something simple like 1 equals 1 or sine squared equals sine squared. But it doesn't always have to be that simple. It could be this big old thing, and our goal is just to get the right-hand side to look like this left-hand side, which has a bunch of stuff. That's okay. So I can do this one, tangent x minus cotangent, which is very similar to what we just did, right? So now we got rise over run, sine over cosine, minus cosine over sine. So my hope is at this point, as soon as you see this, you can relate it back to the problem you just did. Like, oh wait a minute, that's like cosine over sine plus sine over sine. Only thing different is that it's a minus here instead of a plus. So you already know by this example what you should be doing. All right, this shouldn't look like a different problem or like I don't know how to do this one. Well, it's the same problem but with a minus sign instead of a plus sign. So we can follow patterns really carefully if we're looking for them. So we'll have common denominators, we'll do all the same thing, and this will turn into, let's see here, sine squared minus cosine squared. And I was careful to, for the denominator, you might look at this and say, well, it's cosine sine, but the left-hand side is sine, then cosine. So I deliberately switched these around just so it'll match exactly with what my goal is, because my goal is for it to be exactly the same. So you can work that in, or you could write a whole nother step, but if you catch it ahead of time, like, okay, and recognize the denominator, oh, that's where I wanted that denominator, and I got it. So, ahead of time you can write them the same way. Sine of x, cosine x. Alright, so here's a strategy. You're in the middle of a problem. You're like, what do I do next? What happens from here? And you can decide, just like we did up here, once I had cosine squared on the right-hand side here, I'm halfway done because now the denominators match. I just need to get the numerators to match. So same thing here. Right? I have my denominators matching. So I'm halfway done. Now the question is, how do I get the numerators to match? Right? Where do I even start looking and what to do next? Because this is sine squared minus cosine squared. So I can't use my identity. I can't use, cosine squared plus sine squared equals 1. But I can't use that here because it's minus. So that's off the table. Right? I can't just, and I don't want to replace it with 1. I need this right-hand side to equal this left-hand side. So let's do a little inspecting. The right-hand side, or left-hand side, what I'm trying to get has only cosines, right? It doesn't have any sines. So that tells you this is what you need to work with, because your goal is to have cosine squareds. This is fine, right? I want to have cosine squareds. I can leave that alone. This needs to go. If I want to finish this problem, it can't have any sines in the answer, so I know I need to do something about this sine squared x. Right? So you see the little logic there of like, how do I know what to do next? It's like, well, what do I have? What am I trying to get? Something with all cosines. What do I have right now? Something with cosines and a sine. Therefore, get rid of the sine squared, and I'm probably going in the right direction. So sine squared, as we know, right here, equals 1 minus cosine squared. Right? Which is good news. So that I can substitute in for sine squared. So now I have 1 minus cosine squared substituted in for sine squared of x, and everything else stays the same. So minus cosine, that stays the same. All over sine of x and cosine of x. And of course that equals the same thing over here. Alright, so how am I going to prove that this right-hand side numerator equals the left-hand side numerator? Right, so you might look at this and say, well, 1 minus cosine squared x minus cosine squared x. Well, isn't that just the same as 1 minus x minus x? And what is 1 minus x minus x? 1 minus 2x. So that's how we get the 1 minus 2 cosine squared x. Right? These two right here, minus cosine squared x minus cosine squared x, that just equals the minus cosine squared, minus 2 cosine squared x. And I am finished. So it all goes back to knowing basic math. We did fraction work with common denominators from one fraction. We did fraction work with 2 common denominators. We had to, or 2 fractions we had to do common denominators. That's not right. We had a complex fraction. We had to do 1 divided by a fraction. So a fraction within a fraction. All these are just skills from a long time ago that we're applying here. So if you keep that in mind, and then use some critical thinking of asking yourself what goes next and why, then we'll be okay. Tomorrow they'll get a little more tricky. Like I said, we'll use conjugates. We'll use a little bit more than just the basics, but today is just the basics. So you're going to do homework number 6. Right here, make sure you put this at the top of your paper, brand new piece of paper, first and last name, period, number 6, page 195, write it all the way out, and that way we know exactly what it is.